preparing this lesson,
Yes,
um, because of I didn't know where was I going to start. But then yeah, I don't know how far are you with functions.
we haven't
No,
started with functions.
say it again.
We haven't started with functions yet.
What have you started with?
We started with equations and inequalities. So we're done with that
Equations.
chapter. So we're starting with functions tomorrow.
You're studying with functions tomorrow. So,
Yes, sir.
do you mind if I give you the solid foundation? Can I just leave whatever that I'm doing here and start to lay a solid foundation? Because I
Yes, sir.
thought that you are done with functions. So that's why I brought the questions from the
Oh,
previous question papers. You
yes,
see,
sir.
these are the questions from the previous question papers, right?
Yes,
But
sir.
since you bring it to my attention that you haven't started with the function, you are starting up with functions tomorrow. I would like to teach them from scratch. Do you
Yes,
allow
sir.
me to do that?
Yes, sir.
Okay, no, that's wonderful. Let me pray and we start with our lesson. Do you allow me to pray?
Yes, sir.
Okay, Father, in the mighty name of Jesus, I thank you for your loving kindness, your mercies that I knew every morning. Great is thy faithfulness. Oh God, as I'm going to have a lesson with Kuma, I pray, Father, that may I feed her with the knowledge and the information the way her brain can be able to absorb. Father, I pray that this lesson it is specifically tailored for her. Father, I pray in the mighty name of Jesus that, Father, may I not rely on my own understanding and my own experience that I've been doing this for years. But I pray, King of Glory, that, Father, let this lesson be special, Father. Guide me, give me wisdom on how to do it today. In Jesus' mighty name, we give you honor and glory. Amen.
Amen.
Um, so, okay, I want you to understand functions like this. So, let us just list functions quickly. What type of functions do you know? Let us start there. How many functions do you know that you know up to so far in grade 11?
Okay, let me think. Um, I know the basics, which are f of x,
Yes, but I want the types.
or the types.
Yes.
Um, okay, types of functions. Okay, so
There is a
there
straight
are
line.
linear functions, which is
Aha.
the
Now,
straight line, which is
yes,
y
straight
equals to
line.
mx plus c.
Aha. Now I'm happy.
And yes,
Y it
and
is
then
equals
they
to
equals
mx
to
plus.
mx plus c.
Sometimes they say cube, right?
Yes, sir.
Yes.
Oh, yes,
And
sir. Quadratic functions, which is y equals to ax squared plus bx plus c.
y it is equals to ax
Ax
squared
squared
plus bx
plus
plus.
bx plus
Mm-hmm.
c. So it also has a turning point, which is the maximum or the minimum.
Uh-huh. Wow, that's wonderful. Uh,
Yes, sir. And then
do you know
we
that
have
sometimes it also
exponential.
appears like this?
Yes,
X
sir.
plus p close bracket to the
E
power of.
with q.
Yes.
Yes, sir.
Okay. And let us go to number 3.
Exponential functions.
Yes.
Exponential functions is y equals to a to the power of x.
Exponential y it is equals to
A to the power of x.
a to the power of x.
X.
Just like that.
Yes, sir.
Remember, you're
Yes,
in
sir.
grade 11. Did they introduce it this year or they have introduced it last year? When did you start
Last
to hear
year.
about the exponential function?
Exponential. We were doing it. I think it was some parts of equations and inequalities.
Okay.
because my teacher was explaining, and somewhere there it involved um exponential functions.
Okay, that's wonderful. You said when are you
Yes,
writing, or you have written already, or you wrote
I am writing. For this is for test week, so I'm writing in March.
in March? Do you know the specific date?
Let me just check on the timetable. Uh,
Oh, okay. Do you
okay.
think do you think it is possible for you to get a distinction because of this scope is very small?
Yes, sir.
It is possible, right?
Yes, sir.
So, but then we need to put in the work, ne?
Yes, sir.
Oh, okay, good. Yes, let us finish up. Pero we're not done. Number 4, we
Yes,
spoke
sir.
about what is number 4? We supposed to have another one.
Which is okay. I think not sure.
Uh,
It's
in the
is
in the interest of time, I'm just gonna help you. There's hyperbola, ne?
yes, sir. Oh, a hyperbola. Yes, sir.
Yes, and then what is the equation of hyperbola?
Hyperbola is y equals to um. Okay, equation. Hyperbola equation is y equals to um uh it's y equals to a divided by x minus p plus q.
Aha, that's it.
Yes, sir.
Okay,
Oh, okay.
so
Yes, sir.
these are the functions that you should know. But then, of course, they go beyond this. Like, we will dive in deep. We will just make sure that we study them thoroughly. Okay,
Yes,
so
sir.
they have got some features. Some of the features are common, and some of them are unique to certain
Yes,
functions. Like, for
yes, sir.
instance, when we talk about the turning point, in this case, quadratic is the only one that has a turning point.
Yes, sir.
Okay. And we can also talk about the asymptotes. And in
Yes,
this
sir.
case, the quadratic and the hyperbola are the only ones that have asymptotes. So,
Asymptotes. Yes, sir.
these things that I'm mentioning now, they are the things that you are going to be examined on. But the unfortunate part is that they will not ask you that, give us the coordinates of the turning point. They will just give you a parabola like this, and they
Yes, sir.
decide to put alphabet B there, and they start
Yes,
to ask you, what are the coordinates of B? Yourself are supposed to know that the coordinates of B, it is the turning point of this graph, and you
yes,
should be knowing how to calculate the turning point.
yes, sir.
So now what I'm going to do, I'm going to discuss the features of all these graphs, all these
Yes,
functions, right? And after we discuss those features, we check the ones which are common, and we also check the ones which are unique
yes, sir.
to a particular graph. And after we do that, now we go and answer the questions. Like, remember, I said to you that from the exam, they don't really ask you that, Kumo, can you please calculate the asymptotes for us? They just
Yes,
give you a line like that, and then they say, give us the coordinates at the point Q. You should know that point Q, it is the asymptote.
asymptotes. Yes, sir.
Okay, thank you. So let us start with the straight line. I just want to build a strong foundation so that um,
Yes, sir.
uh, now we are going straight to straight line. Okay, we are diving deep into straight line. Remember, the straight line, it is also your linear
Linear
function.
function. Yes, sir.
Yes. So Here's your straight line. With your straight line, it has a feature which is called a gradient.
Yes, sir.
Do you know how to calculate the gradient?
Yes, sir.
Okay, what is the formula for the gradient?
Gradient is y equals to Sir, can you hear me?
Yes, clearly I can hear
Oh,
you.
okay. Because I'm trying to connect my phone to the laptop, so I was wondering if you can hear me. Okay, sir.
Yeah. I can hear you.
Okay, so the gradient formula, it is y equals to y. Oh, sorry, sir. M equals to y2 minus y1 divided by x2 minus x1. That's the gradient formula. Yes.
Mhm. Right. This is
Yes,
the
sir.
gradient formula.
Yes,
Okay.
sir.
So
Yes, sir.
this will help you whenever you calculate the equation of the straight line. Remember
Yes,
the
sir.
equation of the straight line, it is y it is equals to mx
X
plus
plus C.
So you are supposed to identify M for them and also identify C. And a
Yes, sir.
C, it is what we call a Y
That's y.
intercept.
Oh, the y intercept. Yes, sir.
Okay. If I were to ask you to explain to me what is Y intercept in your own words, what would you say?
Y intercept is where x is equals to 0.
Wow, that's wonderful. Where X it is equals to 0. You
Yes, sir.
know, if I were to explain it, that's true. But if I were to explain it, I will say that where our graph touches y axis.
Yes, sir.
Okay, so we are both correct. Okay,
Yes,
so we spoke about the gradient. Once you know the gradient, once you know your x-intercept,
yes, sir.
then you have identified or you have defined a formula of a straight line. Okay, so let me say 2. The other thing that you can get here, it is your y intercept. And then you just told me that the y-intercept, it is where x it is.
X 0.
Mhm.
Yes, sir.
And you have x-intercept. What is happening with the x-intercept?
The x intercept is where y is equals to 0.
Where y it is equals to 0.
Yes, sir.
Okay, so
Yes, sir.
these two features that we spoke about, Kumo, they
Yes,
appear on all the functions. You can get y and x-intercept on quadratic. You can get y and x-intercept on exponential. You can get y and x-intercept on hyperbola.
yes,
But
sir.
then this one, the gradient, especially this one, the gradient,
Yes, sir.
it is exclusively for straight line. Once we go to a curve, remember this ones are curving, they are not straight lines. Once we go to this one, normally they will ask you about the average gradient because of it is they are curvy.
Yes,
Okay,
sir.
so it is very rare, especially in grade 11, to find them asking you the question about gradient on this tree. So
Yes, sir.
the question of gradient in grade 11, it is commonly on straight line.
Yes, sir.
Okay, so those are the things that you need to know about the straight line. I don't think I'm forgetting anything. Let us go to quadratic, of which it has a lot. It has a lot. Quadratic has a lot. Okay, let us go
Yes,
there.
sir.
Mm, quadra.
Also, the quadratic functions, do we use the formula to find A, B, and C, or is it different?
You don't really use the I will give you the formulas which are necessary. It is different. Okay.
Yes.
So I will give you formulas which are necessary for you to calculate. Normally, here the formula that we use a lot. I'm not sure if I heard your question clearly. Can you rephrase it because of I might answer you wrong.
Okay, so sir, so I'm talking about another topic. So I'm thinking of maybe it's the same. So there's the quadratic formula that I know, which is
I know you're talking
minus
about
b plus
y is
minus square root. Yes, sir.
minus b plus minus square root
Minus
of
square root
squared minus
minus
4ac
4ac divided by
over
2a.
2a.
So we use this
This one
formula,
helps you.
the
This
quadratic
helps you to
function.
get the roots.
Oh, the roots. Okay.
Yeah.
Yes, sir. So we don't use it for the functions.
We can use it when we want the x-intercepts.
Or x
Do use it whenever we want the x-intercepts.
Yes, sir.
Okay, so you will just see that. Okay, then let us continue with this quadratic function of ours. So quadratic functions, these ones, do they have a gradient? They do have average gradient, but then here I want to talk about turning point.
Yes, sir. Turning point.
So how do you get the turning point of this function? The turning point of this function, it is always being calculated as minus b over 2a.
Okay.
Okay, so this one will give you the x value at the turning point. Remember, your turning point will have coordinates, right? Two
Yes, sir.
coordinates. It will have the abscissa and the ordinates.
Yes, sir.
Okay. So now, if you want to get the x coordinate, which shows you, remember the x coordinate shows you whether it's a minimum or maximum.
The maximum.
And then
Yes, sir.
it is also this x coordinate again. It is also what we call an axis of symmetry,
Yes,
because
sir.
of the x coordinate at the turning point.
Yes, sir.
It is a line that divides that parabola into two equal parts, or that quadratic. Remember, quadratic, it is a parabola. Were you aware of that?
Yes, sir.
Yes, it is a parabola.
Yes, sir.
Okay, so we have got this formula, minus b over 2a.
Yes, sir.
Right? And that is used for your what? For your
Turning point.
yes, the x coordinate at the turning point.
Yes, sir.
But then now, if you want the y coordinate, let me write it nicely. Let me do this. So I said the turning point, you have the x coordinate and y coordinate. So this is how you get your x coordinate. Kumo, you say minus b over 2a. And then if you want y coordinate, you are going to say f of minus b over 2a. Do you know what I mean by this? So whatever value of x that you would have gotten, you are going to substitute it on your formula. Like for instance, let me say that if I calculate here, I get that my x becomes 2. If I want the y value, I will have to go to my original function. Let's say that our original function was f of x. It is equals to 3x squared plus 4x minus 1. Then if you want the value of y at the turning point, you are going to substitute this 2 here. So it becomes f of 2. You see, that's what I meant here. F of minus b over 2a. Then it is going to be 3 into, where I see x, I substituted with what? 2 squared plus 4 into 2 minus
1. Yes, sir.
Do you get what I meant by this?
Yes, sir.
Okay, thank you. This is the turning point of a parabola.
Yes,
but
sir.
then now, this turning point of a parabola, it is only when it only works for this form of your for this form, ne?
Yes, sir.
X squared plus bx plus c. So if your parabola or your quadratic function, it is in this form, then if you want to calculate the coordinates of the turning point, you can use this minus b over 2a. But sometimes you need the turning point and your function, it is in this fashion. It is in, let me show you, y, it is equals to a over x plus p squared plus q. Okay, so if it is in this form, how are you going to get your turning point? Kumo, this is how you are going to get your turning point. Please pay attention.
Yes, sir.
So your turning point in this case, you are going to, you know how to do it?
Yes, sir. Oh, sorry, sir. The network was on and off, on and off. So I didn't hear you first, sir.
Oh, I'm sorry about that. Let me
Yes,
try
sir.
to explain. So I said to you that this pattern or this
Yes, sir.
this method of getting your turning point, it only works when you are given this your parabola is given in this form.
Yes, sir.
So there are times where your parabola it is being given in this form.
Yes, sir.
When it is being given in this form, how are you going to get your turning point, Kumo? Your turning point, you are going to take what is in the bracket. Can you see what appears in the bracket? So for the x value, you are going to take what appears in the bracket and you equate it to 0. X plus p, you equate it to 0. Then from there you solve x. Then it is going to be x, it is equals to minus p. So your x value will be minus p. But then what will be your y value? Your y value, it's not a problem. You take it directly from that function in that form. Then you write it there.
It's Q. Yes, sir.
So these are your coordinates of the turning point. Let us take an example so that we make this thing so that we can see what am I talking about. Let's say that you are given g of x, it is equals to minus 2 open bracket x minus 1 close the bracket to the power of 2 plus 3. Ask you the turning point. Your turning point in this case, it is going to be 1 and 3.
1 and 3, yes, sir.
Yes. Can I explain it? How did we end up at 1 and 3? You took what was in the bracket, x minus 1, you equate it to 0. Then this is how you got your x coordinate. You take 1 to the other side, it becomes positive 1. So that is why your 1 there is positive. And then you go, you take your y, it becomes 3. You take it as it is.
Oh, yes, sir.
Okay?
Yes, sir.
Any question based on this?
Sir, I have a question. So when we have the quadratic functions, so will they always give us like in the bracket like x plus p to the power of 2 in exams, for example?
No, it's not always, Kumo, like I said. Sometimes it will come in this form.
Yes, sir. Okay.
Remember now I'm only focusing on one feature. Ne? I'm focusing on a feature which is being called turning point. Ne?
Yes, sir.
I'm focusing on turning point.
Turning point.
So, okay, let me take an example on this one. So you understood that one, right?
Yes, sir.
Okay, let me take some time on that one. So let's say, what would you do if you are given this? Y, it is equals to minus x to the power of 2 plus 4x minus 3. and they ask you the coordinates of the turning point, you see now, you cannot just take it there and equate it to 0 and all that. Now, this is a different form. This is the red form, this one, right?
Yes,
So
sir.
in this case, this is where you are now going to apply. Your turning point is going to be for the x value, you will have what? Minus b over 2a, right? And
Yes.
then for your y value, you're going to have f of minus b over
2a.
2a. Thank you. So
Yes,
let
sir.
us do this minus b over 2a thing. So my x value will be, what is minus b? What is b according to this?
B is 4.
It is 4,
Yes,
all
sir.
divided by 2. What is my a?
-1.
-1. So open the bracket and put it nicely there in the brackets. Then
Yes.
you press your calculator. I think once you press your calculator, you will get 2. Am I right?
Yes, sir. 2.
Yes, you got 2. Then now this is your x value, and then it also symbolizes minus b over 2a. So now you can go and get your y. Remember here we said that how are you going to get your y? You're going to say that now this minus b over 2a, we know its value, and then it is what? It is 2,
2. Yes, sir.
right?
Yes, sir.
So now it simply means that I go to my original function, and then wherever I see x, I put what? 2.
2.
So I can say that my y value, it is going to be minus. I see x there, I put 2 all squared plus 4 open bracket, I put 2 there minus 3.
Yes.
Then you press the calculator, and what do you get when you press the calculator?
1.
Minus 4 plus 8. It's going to be, yes, 1. Oh, you are so quick.
Yes, sir.
Okay, so now in this case, the coordinates of your turning point will
X
be
is 2
and
y is 1.
1.
Yes, sir.
So I think now I want to leave the turning point.
Yes, sir.
Did I do justice to turning point?
Yes, sir.
You understand it in both ways, right?
Yes, sir.
So I hope they will not trick you. Ne?
Yes, sir.
Now, let us talk about another feature which is under the turning point. So I'm going to call it 1.1 because of it is still under the turning point. Ne?
Yes, sir.
1.1. Axis of symmetry. You know, Kumo, this thing, they have taught you this thing from I think from grade 6 or grade 7, somewhere there. You remember when they will give you shapes, like they will give you a nice love there, and then they say separate it into 2 equal parts, and
Yes.
you will draw something like that.
Yes, sir.
Yes, that is axis of symmetry. Okay, axis of symmetry, it is a line that separates an object into 2 equal parts. Okay, so here, this 2, it is your x value at the turning point. It is what we call axis of symmetry. Therefore, we can say that the formula for axis of symmetry is the same as minus b over 2a.
Yes, sir.
You get it?
Yes, sir.
So what is axis of symmetry? It is the x value at the turning point. Any question up to so far?
No, sir.
Remember, I also spoke about what? I spoke about the x-intercept and y-intercept. And I said that those two, they apply on all the functions.
Yes, sir.
Okay?
Yes, sir.
So let me check. What can I talk? What am I going to talk about? Spoke about the turning point, axis of symmetry. I do not want to talk about the domain and the range yet. I think I will talk about them. I will make a lesson specifically for those.
Yes, sir.
What am I missing? Axis of symmetry, domain, and the range. Y-intercept. You know how to calculate y-intercept and x-intercept, right?
Yes, sir.
Mm-hmm. What's this? I think now we can go to hyperbola.
Yes, sir.
Before we go to hyperbola, can we just check on how do they ask questions? I think that will help us. Okay, this is your parabola.
Yes, sir.
Determine the value of f of 6. You see, that's one mark. Like that's a free mark there. Can you
Yes.
see what am I talking about?
Yes, sir.
6.1. How were you going to do that?
You're going to okay, so they said determine the value of f of 6. So we're going to use the equation given, which is f of x equals to x squared minus 4x minus 5.
Yes, that's true. How are we going to use it? I agree with you.
Oh, so we're going to use 6, and in bracket we're going to put it where there are x.
Uh-huh.
6.
Exactly that.
Yes.
Exactly that. Hey, look at now. Read 5.2.
5.2, determine the coordinates of A and B. So
Which
for
feature
A,
is that? Which feature is that? A and B. Which feature is A and B? Remember, I told you that when they ask questions, they don't talk about the turning points, wara, but then now you need to know, or what are they asking? When they ask you about the A and B, what are they asking about? What are those?
those are the coordinates.
Yes, those are the coordinates, but then what are they?
I know the answer, but I don't know how to explain it.
Okay, how are you going to answer this? How are you going to answer A and B?
What is this?
You see?
Let x
Okay.
be 0.
Let what?
Let x be 0.
You see, now that's the problem. If you do not know how to identify the features,
Yes,
or
sir.
if you do not know how to identify things, then it becomes a problem because of you didn't know how to solve them.
Yes, sir.
Okay. Let's go back to our information. I didn't speak about a lot of things. I spoke. Okay, let's check. On straight line, what did I talk about?
You talked about the gradients and the y-intercept and the x-intercept.
And then definitely those are not. This is not. That is not a straight line. So of course it won't be a gradient. So, but then, can it be y-intercept? Can it be x-intercept?
No, sir.
Yeah, it is y-intercept. I mean, it is x-intercept.
It's x-intercept, yes, sir.
How do you calculate x-intercept?
Let y equals to 0.
You see, now you were saying let x to be 0, and then you were going to get it wrong
Yes,
because
sir.
of you didn't know what are they. So these are the x-intercepts, Kumu. What
Yes,
are
sir.
x-intercepts? Your x-intercepts are simply where your graph passes x-intercept. You see, this is your x-intercept, right?
Yes, sir.
And then your graph, all of a sudden, it decides to come and pass here. It crosses your x-intercept.
X-intercept.
I mean x-axis, not intercept. This is x-axis.
Yes, sir.
Okay, so I want you to put in your mind that whenever you see a graph crossing the x-axis, then you will have x-intercepts. And wherever you see your graph crossing the y-axis, then you will have the y-intercept.
Yes,
because of now, here they were asking you that you must calculate A and B for them.
Yes, sir.
And you said that you are going to make x 0. And then that was not true.
Yes,
so
sir.
you were going to calculate this one. You see here, this is where you are supposed to make x 0. What is this part?
It's
What is
the
this?
y-intercept.
Yes. And y-intercept, how do we calculate it?
Let x be equals to 0.
Let x be 0. Simple as that.
Yes, sir.
Okay, so if you can hold those ones like that, let me see if they ask this question somewhere here. I think they only ask you about the x. Yes, they only ask you about the x-intercepts. But like I said to you, that they never say calculate the x-intercept for us, Kumu. They always ask you about the coordinates. They say that calculate A and B for us. If you do not know that they are x-intercepts, then you will miss the question.
Yes, sir.
You get it?
Yes, sir.
Okay, cool. We were talking about parable. I didn't want to go further, but let us go to this one. Oh, check now. B. Can you see B?
Yes, sir.
What is B?
B. Ooh, it's a.
Which feature is that one?
Oh, now it's clear. B. To show that B is equals to a half. So B is f of x.
Remember, myself and you, Kuma, are talking about features. Ne?
Oh, features. Sorry, sir.
You know, when we talk about elephant, we will be having a tail, we will be having the big ears, we will be having the elephant tusk, and that straw. What do they call it?
Yes, sir.
What do they call this thing, Kumo? That nose of elephant.
It's the
Yeah, then we know
the exponential function.
Yeah, but what I want like, what is that? What is that nose? What do they call it? Like
The
in
trunk.
English? Yes, the trunk.
Yes,
So
sir.
when we talk about elephant, so we talk about different parts, like animals. Can you imagine these functions as animals? They might have common parts. Like for instance, if you take what can I say? If you take octopus,
Yes,
it
sir.
has 8 legs.
Yes,
It's
sir.
not like other animals. You take elephant. Elephant has
A
the
trunk.
trunk, which other things do not have. So when I ask you about the features, I want you to tell me about the parts. So I was asking you about B. What is B? B, it is your y-intercept. Why? Because of the graphs there here are crossing what? Are crossing your
y-intercept.
Y-intercept, exactly.
Okay, yes, sir.
So listen, now they listen what they say here. They say that write down the coordinates of B. You know why they gave it 1 marks?
Yes, sir.
Because of it's very easy. You are just going to take it and plug it there.
Yes, sir.
Okay? The coordinates of B are like this. So whenever we calculate y-intercept, what do we do to x?
X is 0.
X is 0. And then if you can check there, it is a straight line and the exponential function. So
Yes,
we know
sir.
that if we check our straight line, check the straight line. It is here. It is g of x. It is equals to 3 over 2x
x
plus
7.
plus 7. What is this 7?
Yes, sir.
What is it? This 7.
Oh, 7 is the turning point.
Ah.
Oh,
Straight
sorry,
line
sir.
is
It's the asymptote. Yes.
straight line is an asymptote. Remember, we're talking about straight line.
Yes, sir. Oh,
So
the
the straight
straight
line.
line. Yes, sir.
Let's go back. Y is equals to mx plus
Plus
c. This is
E.
the straight line.
Yes.
We said, what is this?
Is the
Gradient.
is the gradient? Yes. M is the
And
gradient.
then what is this?
C is the. It's not.
Y-intercept.
It's the y-intercept. Yes.
Yeah, so the reason why they were asking you this question and then they gave it 1 marks, it's because of they know that okay, when we get y-intercept, x will always be
B0.
and then your y-intercept it's there. It's given 7. You just write this. Then that is why it was 1 marks.
Okay, now I understand. Yes, sir.
Okay?
Yes, sir.
So let us build up. What do I want to talk about now? I spoke about this axis of symmetry. I'm tempted to talk about the domain on this one.
Yes, sir.
Should I go to hyperbola or should I talk about the domain and the range of this function of the parabola? Okay, let us talk about the domain and the range of the
Yes.
parabola.
Yes, sir.
I'm going to try to be slow because of actually I prefer to teach domain and the range when you are very, very, very fresh, like you have rested.
Yes, sir. Yes, sir.
Because it's a bit tricky, but
Yes,
it's
sir.
easy. So let's put it aside. Let's go and talk about the hyperbola. Ne?
Okay. Yes, sir.
Yeah, let us talk about the hyperbola. But remember, we are not done with this one. Ne? With the
Sir.
parabola, we will still come back. So let us talk about the hyperbola.
Yes, sir.
Hyperbola. Oh gosh. Okay. So whenever we talk about a hyperbola, Kumo, it has the x and y intercept. I want to emphasize this.
Yes,
So
sir.
it still has what? It still has the x and
It's
y
X and Y
intercept.
intercept.
So the x and y intercept, they are generic. All these functions, they have them. But turning point, it is only at the parabola.
Parabola. Yes, sir.
Okay.
Yes, sir.
So now I want to talk about the hyperbola.
Yes, sir.
When we talk about hyperbola, y it is equals to a over x plus q, right?
Yes, sir.
Now the hyperbola has what we call asymptotes.
Yes, sir.
One asymptotes. And how do you get those asymptotes? So it has the y asymptote and the x asymptote. So now
Yes, sir.
check. How am I going to get my asymptotes? I'm just going to say that y it is equals to, I take it straight from here.
Yes, sir.
Okay.
Yes,
So
sir.
it is q. And then for the x, I take the value that comes after x. And in this case, we do not have anything. Can you see that we don't have any value after x?
Yes, sir.
So my x in this case, it will be 0.
Yes, sir.
Let me take a specific example. Remember, I'm talking about asymptotes, right?
Yes,
So
sir.
in this case, I'm going to say that y it is equals to 8 over x plus 2. This is a function which is called hyperbola. How do you know if it's a hyperbola, Kumu? How do you see it?
That is the asymptote in the hyperbola.
Okay, can you see that there's asymptote if I write it like this?
No, sir.
So how do you know if it's a hyperbola?
Because of y?
But all of them, they have y. Remember even those ones we were writing them like this?
Yes, sir.
So most of the time your hyperbola,
Yes, sir.
it is the only graph that has a fraction.
Yes, sir.
And each fraction, it has a variable, like the denominator of the fraction. If you check all our functions that we have done, none of them had a fraction and which has a denominator as a variable. So in this case, you see my denominator, it is x. And then it is a what? It is
It's
a variable.
A variable, yes, sir.
Yes. So Coolio, now we wanted to give the asymptote of this particular hyperbola.
Yes,
This
sir.
one was general. Then I was showing you the general information. So the asymptote of this one, it will be y, it is equals to 2. Oh, minus 2. Sorry about that.
Yes,
Oh, it's
sir.
plus.
It's plus, yes, sir.
So y is equals to 2. Then x will be, there's nothing here.
Yes,
Then
sir.
0. I know that I triggered your curiosity, or what do I mean when I always say that there's nothing?
Yes,
There
sir.
comes a time where now it is advanced. I think now you are in grade 11, right?
Yes, sir.
I think in grade 11 now, the form of hyperbola, it has advanced to this.
Yes, sir.
Y it is equals to a over x plus p plus q.
Yes, sir.
Okay, so now in this case, this is where you are going to have your y it is equals to q as an asymptote, and you are going to have x plus p, it is equals to 0. Then you solve x, then you will get x it is equals to minus p as your asymptote.
Yes, sir.
Okay, so
Yes.
let me do these things in like let me make them more practical. I believe in making things practical because of I believe that most of you learn easier when things are practical.
Yes, sir.
Let us say that you have y it is equals to 1 over x plus 2 minus 8. Right?
Yes, sir.
Y is equals to 1 over x plus 2 minus 8. Then they ask us about the asymptotes of this function. Kumo, remember I said to you that it is it is not only hyperbola, but then I'm starting to talk about the asymptotes on hyperbola. We
Yes.
didn't have asymptotes when we were talking about the parabola.
Yes.
Even when we started with straight line, we didn't have asymptotes. We are just starting to talk about the asymptotes now on hyperbola.
Hyperbola, yes, sir.
Okay, so they ask us what are the hyperbola? Determine the asymptotes. I'm sorry.
Yes, sir.
Determine the asymptotes of this graph. So our asymptotes, vertical asymptotes. We've got the vertical asymptotes and the horizontal asymptote. Do you know what does the word vertical mean?
Vertical is from up to down. From top to down. Yes, sir.
Yes, from top. Yeah. So vertically, it is this. If I were to put this phone up right, and then horizontally, it's this.
Yes,
Okay.
sir.
So we will say that normally vertically has to do with your y.
I intercept.
Yes, y axis, and then horizontally has to do with your
Your
x
x-axis.
axis.
Yes, sir.
Okay. But now, please hear me very well.
Yes, sir.
Hear me very well, Kumo. So in this case, as much as this one has to do vertical has to do with y-axis.
Yes, sir.
But then when we come to asymptotes, our vertical asymptote will have to do with the x.
Intercept.
Will have to do with x plus 2, like your denominator.
Yes, sir.
Okay, so I'm gonna take my denominator here. You see now it has something. That's what I meant all along when I said that it didn't have anything here. It was only x, but then now there's x plus 2. I hope
Yes,
now I'm making more sense. So
yes, sir.
This is how I get my vertical asymptote. I take my denominator here.
Yes, sir.
X plus 2, I equate it to 0. Then I solve x. Then my vertical asymptote will be minus 2. Then your horizontal asymptote, you don't have to stress a lot. Just go and take this thing as it is. And then that will be your horizontal asymptote. Then that
Yes, sir.
are you fine with asymptotes?
Yes, sir.
Can I ask you a question
Yes,
to check
sir.
if you are learning?
Yes, sir.
Okay. So I want the vertical and the horizontal asymptote from this. Ne?
Yes, sir.
So let me give you this. So you have y is equals to 2 over x plus 1 plus 2. Kumo, may you please give me my vertical asymptote and my horizontal asymptote?
Okay, so your vertical asymptote, so it's going to be x plus 1 equals to 0. So x is equals to negative 1.
Negative 1.
Yes, sir.
That's true.
And then your
What about
your horizontal axis is y equals to.
horizontal asymptote? I feel for you. I can tell that you are tired, but then we are almost done. Don't worry. My
Yes,
horizontal asymptote.
horizontal asymptote is y equals to plus 2 or is 2.
Y is equals to
2
2.
positive 2.
Simple
Yes.
as that. So
Yes,
you
sir.
promise me that you won't forget about asymptotes.
No, sir.
So you have 2 of them, right?
Yes, sir.
You have the vertical asymptote and the horizontal asymptote.
Yes,
And
sir.
you promise me that you won't forget about axis of symmetry.
Yes, sir. I promise.
You promise me that you won't forget about the turning points, how to get the turning points from different forms of parabolas.
Yes, sir.
Okay, let me just give you one last thing.
Thank
A
you,
lunchbox.
sir. Yes, sir.
It's not a lunchbox, it's a supper box. Sorry. Supper box, and we are done. I promise you that we are done.
Yes.
So now I want to talk about axis of symmetries on a hyperbola. Remember, I spoke about it on a parabola. Do you remember that?
Yes, sir.
I spoke about axis of symmetries on a hyperbola.
Yes, sir.
Okay. So now I want to talk about them from a point of hyperbola. So this one, maybe you can even screenshot it. Are you still on your phone?
Yes, sir. I'm still on my phone, sir.
Yes, you can screenshot it and then digest it nicely. For now, just try to hear me, but you can digest it nicely after you have rested.
Yes, sir.
So, axis of symmetry. So remember, Kumo, when we were talking about this from parabola, it was only one. Now, if you check this is plural, ne?
Yes, sir.
There are 2. Okay.
Yes, sir.
So now, on this one, you are going 2.1, you are going to have the one with a positive gradient.
Yes, sir.
Allow me to abbreviate it AOS. Then I do this positive M. We are mathematicians, Kumo. We can't keep on writing long things. Axis of symmetry of a positive gradient. I hope you'll get it. Okay, because of M, it is a gradient, right? This is positive, and then AOS, we agree that it is excess of symmetry, right?
Sir.
So for excess of symmetry of a positive gradient, this is the formula that you are going to use. Y, it is equals to X plus P plus Q. Simple as that.
Sir.
You memorize it, you are done. I'm going to show you how is it applicable. 2.2, right?
Yes, sir.
Excess of symmetry with negative gradient. AOS negative M. How is this one calculated? Y, it is equals to minus X minus P plus Q. Simple as that.
Yes, sir.
So now, remember that this excess of symmetry, we started to talk about it when we were still doing parabola. And now we are doing the two of them because of we are doing what? We are doing hyperbola. Let me just give you a bit of explanation so that you can get it. Why do we have two of them? And on the other one, we have one. So this is parabola, right? So parabola, if I cut it like this, you see, I can manage to get two equal parts because if you check the part which is on the left and on the right will be equal. But then now if I start to try to do something like this, now the top part is not the same as the lower part.
Yes, sir.
You get it? Even if I try to do like this part is not the same as that one. If I try to do like this part is not the same as that one. But then when we talk about the hyperbola, remember hyperbola is something that looks like this. Right? It is a graph that looks like this.
Yes,
so if I draw like this, the part which is this side, it is the same as the part which is that side.
Yes, sir.
And then I can also do this. The part which is this side, yes, sir. It is the same as the part which is this side. So do you understand why it has two axes of symmetries? It is because of that.
Yes, sir.
Okay?
Yes, sir.
So let us do the application, then we are done. In 2 minutes, we will be out of this class.
Yes,
okay?
Sir.
I just do the application, then we are done.
Yes, sir.
Okay, so we have y, it is equals to 1 over x plus 2 minus 8. Then we want to find the axis of symmetry of this. Remember, we have two of them, ne?
Yes, sir.
So equations, this is my shorthand for equations, ne?
Yes, sir.
Or AOS. We said AOS, it is what?
AOS is the axis of symmetry.
Thank you. At least you are still with me. So we want to find the equations of axis of symmetry. Remember, we have the positive one, the one with the positive gradient, the one with the negative gradient. So let us quickly write them down. X, it is equals to, no, Y, they are Y's. Y is equals to X plus P plus Q. Then Y, it is equals to X. We do not know X. But then now we know what is P and what is Q. Remember, what is my P?
Yep. P is the.
Remember me answering this question.
Yes, sir.
What is P there?
P is 2.
Yes, P is 2. So I just say plus 2.
Yes, sir.
Plus, what is my Q?
Q is negative 8.
Negative 8. Right?
Yes,
so
sir.
This is the one with the positive gradient, right? Let us do the one with the negative gradient, ne?
Yes, sir.
So y, it is equals to minus x minus p plus q. I wrote it well, right?
Yes, sir.
Y, it is equals to minus x, we leave it like that, minus p, we said it is what? 2.
2, yes, sir.
Plus q, what is my q?
Is
Minus
negative 8.
Negative 8. So here it's a matter of simplification, then you will get them.
Yes, sir.
Okay, so check. Let me simplify this. Y it is equals to x plus 2. Positive times negative, it is negative, right? Negative 8.
Yes, sir.
Then it simplifies to x minus 6.
Minus 6.
You get me?
Yes,
And
sir.
here it will simplify to minus x minus 2 minus 8.
Yes,
Then
sir.
y it is equals to minus x minus 10.
Yes, sir.
Okay, so if you check now these equations, Humu, this
Yes,
is
sir.
an equation of a straight line.
Yes,
Can you
sir.
see that? This is an equation of a straight line. Even this one is an equation of a straight line. So this one, they say it, remember we said it is of a negative gradient because of if you check Vele, our gradient it is -1. And then
Yes.
if you check this one, our gradient it is +1. So this line, the red line, will be going like that if you sketch it. And then the purple one will be going like that.
Oh, yes, sir.
Okay, and then our hyperbola, because of this value here, it is positive. I think it is going to take this form. It is going to be on quadrant number 1 and 3. So it is going to take a form like that. Yeah, something like that.
Yes, sir.
So you know how to apply the equations of the axis of symmetry, right?
Yes, sir.
So remember, axis of symmetry, we did it on parabola. I'm doing an emphasis now. I'm repeating myself. On a parabola, when they talk about the axis of symmetry, they talk about the x value at the turning point.
Yes, sir.
But here, when they talk about the axis of symmetry, we have the one with the positive gradient and the one with the negative gradient. And they
Yes.
have formulas. And their formulas are here.
Yes, sir.
Any question up to so far?
No, sir.
We have pushed, girl. And then thanks for your cooperation. And thanks for giving me some time, because of I understand that you are busy. But then keep up the good work, and then you will definitely reap whatever that you are sowing. Much
Yes, sir.
appreciated, Kumo. Enjoy the rest of the evening with the family. I might send the work testing you on this.
Yes, sir.
So if you are not tested, then you're gonna forget them.
Yes, sir.
Oh, okay. Okay. You know what? Let's before I stop this lesson, can we try to finalize your lessons or fix them?
Yes. Yes.
Which days do you think that are more convenient for you?
On Tuesdays and Thursdays, and Tuesday and Thursdays, and maybe Fridays, but Fridays later, like around
Okay,
4 or 6. Yes, sir.
okay, so we'll check. Yeah, maybe if we miss Tuesday and Thursday, we will run to Friday. But then for now, let us keep Tuesday and Thursday. Ne?
Tuesday and Thursday, yes, sir.
Yeah, Tuesday and Thursday, same time, 7. Today, what delayed you?
What delayed me is I had orchestra street, and then my dad had to fetch me. So Ochesaka 6. So he arrived at school 6:30, and we also had to wait for my sister a whole 10 minutes. So we arrived like here at home like 8 minutes past 7.
Okay, no, I get that. Because
Yes,
of mostly I prefer you to rest, have a rest nyana before we go and jump to our lesson. But then otherwise, thanks for your efforts that you made it to our first lesson. In our next topic, I think I will be talking about the exponential, and maybe I will be able to touch domain and the range. And
yes,
then
sir.
what are you doing on weekends, Saturdays and Sundays?
Sir?
On Saturdays and Sundays?
On Saturday, I'm not doing anything because I left another orchestra that was like Fridays and Saturdays. So I left that orchestra. So Saturdays I'm free. And Sundays I'm going to church, so I'll be back like at home around 1 o'clock or 2 o'clock.
Yeah, same here. But Saturdays I also have rehearsals. I'm a pianist, so
Yes,
Saturday I have rehearsals, and Sunday I go to church. I come back around 1. But then yeah, we'll check how can we do it. But then for now, let us say that we are using Tuesday and Thursdays at 7.
yes, sir.
Okay, bye, Kumo.
Bye, sir. Thank you so much, sir.
Okay, much appreciated.
Oh, sir, before I forget, when we're done here, can you please send me the whole video of our lesson so I can recap some
Yeah,
stuff? Yes,
sure
sir.
thing. I'll do that.
Yes,
I'll
sir.
do
Thank you,
that just
sir.
now. Bye.
Bye, sir.